right, so we're reviewing for Summative 10, and there are 4 sections on this summative, none of which are old, and none of which will be retaken in class. You'll have to do your own retake, because we're moving on to sequences, and that quiz is going to be one quiz that covers all of sequences, which is like 5 sections. It is likely the last quiz. We'll see if necessary, we could fit in a retake sequence and limits quiz if we had to. All right. So this particular section is basically, can you draw a vector and find its components, and then do that, the weird notation operations. So you might have a question like this. This is number 53. It's on the bookwork. Okay, so it's on the back of the gold sheet. Player throws a baseball with an initial velocity of 55 feet per second at an angle of 25 degrees above the horizontal as shown. Find the magnitude of the horizontal and vertical components. Okay, so on your paper, would be drawn like this. Sorry, I don't know where I put that down there. And how would you find the horizontal components? What if it just said find the horizontal components? Which ones are the horizontal? The x, okay. What's the rule to find the x? That's to find an angle. We already know the angle. So 55 cosine of 25. In what mode? Degrees. This would be the horizontal component. One of the questions asked for only horizontal or vertical. If it said vertical, it would be sine, so it would be 55 sine of 25. Mode is an issue on this quiz. I am in degrees. 55 cosine 25, 55 sine 25. The horizontal component is 49.8 feet per second, and the vertical is 23.2 feet per second. And you don't really need a label there, as far as I'm concerned. Are we good? Any questions? Okay. This is the same question with 200 newtons times, not the same question. What's going to be different here? Anybody reading this? It says below the horizontal, 200 newtons. So you would do negative 20 degrees, but you would do the same thing, 200 cosine of negative 20 and 200 sine of negative 20. And you should get a positive and a negative answer, right? I got 187.9 and negative 68.4. Anybody else getting that? Okay. Andrea? All right, this is an extra question that, is it maybe on the actual review sheet? This is the one that's on there? Okay. It says sketch and find the horizontal and vertical components for this vector. And it says this. What do we have to do here? Okay. No, we don't start at west. Everything in this notation from our book says you start from the north-south line and you go 32 to the west. okay? And it's 100 miles an hour. This is on the white sheet up there. But how do we find the components for this, guys? We can't just type 132, cosine 32, 100, sine 32. That only works when we have what? Angle off the, yeah, positive x-axis. It won't get the signs right unless it's off the positive x-axis. So 90 plus 32, is that 122, guys? Did I add right? Okay, so we'd have 100 cosine 122, 100 sine 122. I got negative 53 roughly, because it's 52.99, and 84.8. Anybody else getting those? Does that seem right, guys? Left and up, right? Okay. And because it asks for both horizontal and vertical, I probably even gave you this on the quiz, okay? Right. That's the issue, okay? If you don't use the off the positive x-axis, you will not get the signs right. You'll have to watch the signs yourself, okay? All right, this is off worksheet 9A, it says. Or it's bookwork assigned on 9A, but it's actually shown on the gold sheets. Kind of, it's 21 and 22. All right, this, I don't know why this is so hard for students, but when you're given the ordered pairs, asked to find the component form. Okay, thanks. And then magnitude. That's it. Okay. So the idea is if you're going from -8, -4 to +6, +1, you're going this way because it says A to B. It will help if you draw a sketch. You certainly don't have to. Anybody remember how we find the components? That's going to be the magnitude, but it's not the components. The formula looks like this, but we just really used our brain. We said it goes from -8 up to +6, or to the right to 6, which is 14. And -4 went up to 1, which is up 5. Or 6 minus -8 is 14. 1 minus -4 is 5. Okay? Because you're reducing, these were ordered pairs, and you're trying to say what is the direction, how much is it going left, right, up, down to get from one to the other. All right? And it matters that it's A to B. If you gave me those same numbers with opposite signs because you subtracted in the other order, that's B to A. Okay? This particular one should be going right and up, so it's this. The magnitude then is what? Square root of 14 squared plus 5 squared, which you could go back here and do the distance formula, okay? It's the same answer. We're just, since we already have the components, we can do this. 196 plus 25 is square root of 220. Did someone get that? Decimal is fine. 14.8. I don't think you have to do direction on this one. Okay. If you did, it would be inverse tangent y over x. And it would be 19.6 degrees what? look at the blue and where the arrow is. This 19.6 would be off the horizontal, okay? Because it's in quadrant 1. I don't think you have to do that on the quiz. You need to do another one of those or not? Maybe just the first part? What is A to B components for number 22 right here? She right? Okay. And then the vector operations with these, I hope this is like the easiest question on the quiz. Do you remember this? Yeah, it says 2q minus p. So 2 times this vector minus this vector. So just be careful that you copy them down correctly, you know. That would be -4, -6 minus 4, 0, which would come out -8, -6. How did I do? Okay. Can I be done with that kind? You're good? All right. So that's all in the first section of the quiz. Seem okay? Right. The second section of the quiz is adding vectors, whether it's application or just adding two that are drawn or, okay? And you can use components or you can use another method. That's up to you. You just have to get the same answer I do, which is entirely possible by different methods. But the first question is very basic, okay? Anybody know how we're going to add these together? Yeah, I would just do 3.4 cosine of 25, or 75, sorry, I can't read. 3.4 sine of 75. But I wouldn't even bother to do that. I would just add it together with the other one as I go. So I'm going to add these together. And then I'm going to add these together and end up with two components. So 3.4 cosine of 75 close parenthesis plus 2.8 cosine of 50. Anyone get 2.7 for that or 2.68? Or no? Yes? And 5.43 if I round to 2. Find the magnitude of the resultant in centimeters and its relative direction to the horizontal. So now what? Because this is not the answer. Okay. What this is saying for those physics people is if I were to go 50 degrees up and out 2.8, and another force is going 75 degrees up and out 3.4, that where this will wind up is over 2.6 and up 5. It's going to wind up here somewhere, okay? If you were to think of it as tip to tail, what would happen is that blue one and that red one would make a parallelogram, and the black one that's the resultant would be the diagonal, okay? Is that kind of making sense to tie it together? But all I want to know is how long and the angle that black one's making. How do I do magnitude? Pythagorean theorem. And direction is going to be inverse tangent. But then we need to describe that direction. We might need to describe it. I don't know that we do for this question. All right, 2.68 squared plus 5.43 squared, square root of that. Oh, yuck, yuck, yuck. Type that Messy. If I get 6, roughly, maybe 6.1. Yeah. Would have depended how we 6 or 6.1, depending how we rounded along the way. If we'd rounded less along the way, it does go only 1 decimal in both of these up here. So, all right, inverse tangent 5.43 divided by 2.68, 63.7 degrees. Anyone? With the horizontal, it says find its direction relative to the horizontal. Is that what we did? Okay. I don't think you'll have trouble on the quiz with that question. If it had pushed into the second quadrant, okay, then it gets a little messy. But I think it's a first quadrant one on there. All right. This, I'm not sure this exact kind of question is on the quiz, but it says a force of 27 newtons pulls at an angle 23 degrees above due east. A weird description, huh? Okay. A second force of 33 pulls at an angle 55 below due west. So this is a 55-degree angle in here, but when we go to do the components, we're going to want to do some magic here. So I'm thinking it's going to end up pulling this way. What do you think? Somewhere? But not very far, because they're almost against each other, right? Actually, maybe down here more, because this one is stronger. It doesn't look like it on my picture. I didn't draw it longer, but all right, this one's easy. 27 cosine of 23, 27 sine of 23. This one we need to use what angle? 180 plus 55 is 235, is that right? Because it's acting down and to the left. You could use 55. You just have to make them both negative, okay? If you use the 235, it'll take care of it. 33 cosine 235, 33 sine of 235. Okay, anybody adding for me real fast? I got 5.9 for this one. Anybody? Okay, that's to the right. And negative 16.5, anybody get that? Okay. Magnitude, we need to square that, each of those, and add them together and do Pythagorean theorem. 17.7. Okay, so the resultant was over here and down here, but it was not 27 or 33. I got that it was only 17.5 units long. Did you get that when you did magnitude? Is someone not getting these answers? Why is it so quiet? I got 17.5 as the magnitude of the resultant. No? Yes? Okay. Now, to figure out the angle, if we do inverse tangent from here, are you in degrees? Are you closing your parentheses? Did you get it, Reagan, or figure out what's going on? Did you do cosine and cosine and sine and sine? Because sometimes I... Did anyone else not get 5.9? Did someone else get 5.9? For that one? Adding the x's? Are you in degrees? 27 cosine 23, close parenthesis. plus 33 cosine 235, close parenthesis.
Oh, okay.
Okay, yes. It's 235 degrees around there. Sorry, it's because it's 180 plus 55 into that quadrant. All right. I got negative 70. Did anyone get that? So the resultant force, the way they've described it, they said above due east or below due west. Again, this question isn't phrased exactly like this on the quiz, but I would say below due east. Okay? Because if they're going to describe everything off of due east or west, isn't that what we have here? A negative 70.3 degrees. How do I know what quadrant it's in? How do I know that I've drawn it correctly? Right here, right? Right and down. Quadrant 4. So this is in the right quadrant. So that's the right angle. It's just how would we want to describe it in words? And again, it's not on the quiz. So I would have said 70.3 degrees. What did they say? Below due east? Or some version that gave you that. I don't know. All right. I'm trying to see which of these is more like... yeah, I'm skipping this one. Let's do this one. An airplane is traveling due east with a velocity of 620 miles per hour. So what do you want to give me for components of that plane? You could do just 620, 0. If you wanted to type 620 cosine of 0, 620 sine of 0, it would give you the same thing because it's 0 degrees of rotation off the positive x-axis. Okay? The cosine and sine right there are 1, 0. All right, a wind blows at 60 miles an hour at an angle of 50 degrees with the horizontal. So it isn't pushing it into another quadrant. The way it's described is it's pushing it this way. Okay. It doesn't say, if it said from, you'd draw the little wind here and put the arrow on the other end. On the quiz, if it's supposed to go through the picture and come out the other side, I drew it for you. Okay. With the arrow on it. So you know which way it's pushing it. If this had said from, maybe I should just look at the quiz and do it the way it is on the quiz. Where from? It's from on the quiz. So let's change this question to from. Okay. If it said from an angle of 50 degrees, this would be 50 degrees, but the wind is blowing from this direction, howling, pushing the plane this way. So this is what it looks like on the quiz. Okay. So now you need to decide what components to put on there to make this 60 mile an hour wind push in that direction. So the plane is going to be 60 cosine of something and 60 sine of something, but what do you want to do? 180 plus 50? Because that's the quadrant, right? You could do 50 as long as you remembered to make them both negative, because the quadrant is negative, negative. All right, I'm going to do 60 cosine of 230 60, sine of 230. So I got 581.4 when I added those two together. And negative 46 roughly. Anybody? Yes? Okay. So the magnitude of the plane. So this is what's happening to the plane. It's winding up, going this way and down a little bit. Okay, this is the actual flight of the path. Flight of the plane, sorry. So magnitude or ground speed is really what we're calculating now, is Pythagorean theorem. What'd you get? 583.2-ish. Anyone in there? 583 is fine. Did you forget that when you square this, it becomes positive? What did you type exactly? If you're doing it, the only way that it went down was if you used a negative somehow. Okay. Okay. So the plane's speed is 583.2 miles per hour. How do we find the direction? Because the question says, and how far off course the wind is blowing the plane, and that's how it's phrased on the question. Okay. So I didn't make you give me some kind of crazy north of south, south of east, east of west, true bearing. Okay, it just says how far off course. So the plane was trying to fly due east. If we do inverse tangent of negative 46 over 581.4, you get 4.5 degrees off course, or negative 4.5 degrees, yes? And the negative just means that it's going to the south, right, of where it wanted to. But if it wants to know how many degrees off course, you can ignore the sign. Anybody not getting that? Okay. Have we killed vectors? Okay, no crying. Oh, I gave you an extra one. Is this the one that was on the sheet? Okay. An airplane is heading due south. Okay. Due south. So its components would be 0, negative 450. Could use cosine. You could do 450 cosine 270 or negative 90. But there's a wind blowing from the southwest. Okay. Southwest. Yeah, it doesn't need an angle. It's directly southwest, guys. And that's, I think, how it is on the quiz, honestly. It's not southwest on the quiz, but this is when it says just southwest, southeast, northeast, northwest, it's telling you at a 45 directly, okay? It didn't give you the angle. But it says from, so the picture would look like this on your quiz. So what angle are we going to do? Yeah, just be 45 off the x. So we're going to add 85 cosine of 45, 85 sine of 45. Where'd I get what? You're good. I just didn't know if there was something I was not explaining well. Okay, magnitude. 394.5, anyone? So did it help or hurt the plane? The plane was trying to fly 450. It slowed it down, right? Okay, because look how it's pushing the plane back away from there, okay? And then the angle off course, if we do inverse tangent, negative 389.9 divided by 60.1. Now, this is where someone's going to get a little... Is it blowing the plane 81.2 degrees off course? No, this came up negative 81.2. Did someone get that? So that's where it's flying. But what was it trying to fly? This guy, negative 90, straight south, right? So the difference is 0.8 degrees. Okay, feel a little bit better about that, kind? All right, we got to get going. There's 2 more things we need to cover, okay? This polar graphing, okay, covers graphing points, distance between points, and giving other names, as well as basic line and circle graphs. I hope this one's pretty easy. So real quick, W is in degrees, so I go over to this graph paper, go around to 210, but then do what? Backwards half, so it'd kind of be in here. That's a weird one. This is bookwork, so it's on the back of the gold sheet, probably without a graph paper though, huh? Did I draw extra on your sheet? I don't know. On the white sheet, I didn't give you any of these. Okay. Number 12 is in radians. 7 pi over 4 is where, guys? You'll have a unit circle, right? So you'll be able to find 7 pi over 4 if you're confused. 1.5 would be here, and that's x. Am I losing anybody? Going too fast? Okay. Rotate negative 120 in degrees. Negative 120 is to positive 240, right? This is the same as negative 120. And then it says out 4. Remember to count that first one. These are even labeled, so it should be here. And then z is 5 pi over 6. Positive 5 pi over 6, but backing up 3. Be careful. That should be the 11 pi over 6 line, right? Okay. There wasn't a negative negative up there. Do you need to see a negative negative? If it said negative 45 degrees, negative 2, you would go down 45 here, but then back up 2, so it would be over here. If I call that A. We all comfortable with the graphing part? All right, the second part is very basic graph either. What is this one? If it's theta, it's a... What's 17? A circle of radius 7, which doesn't fit. If I change that to 2, if it said r equals 2, that would be that graph right there. But what's this one, guys? Theta equals negative... Yeah, that's a line. Negative 60 degrees is negative pi over 3. So that's this line? No, this line. So it would be this line right here. I think it's a multiple choice question, guys. Just pick the right equation. All right, write multiple names. This is on your sheet? Okay, this is on the review sheet, right? Okay. So was I nice to put the one on the quiz on degrees? It is in degrees, I think, on the quiz. But remember, it's multiple choice, so you're going to have to be very careful to pick one that's not correct. It says which one is not correct. Okay, we're not going to do that. Just tell me what you know. If you went around 120, you went out 3. Okay. What else could you tell me? -3 and -60. There's a tricky one. Okay. So you went this way 60, but then backed up 3. What if you didn't go negative the 60? Instead, you went what? Positive 300, -3, and -240 and positive 3. Okay. No questions on that stuff, especially since it's multiple choice. I'm not going to do more practice then. Are we good? Okay, find the distance between a pair of points, and they are given in degrees. And the formula is on the back of the yellow sheet if you prefer to just use the formula. Okay? The formula works, but you're going to have to type very carefully if it's negatives. The Hofbauer method would say go to -45 degrees and back up 1 has a better name. Can you give me a better name for that one? 135 and positive 1. Okay. And the other point is at 270 and out 6. Okay. So if I am going to be me and just be lazy and use law of cosines, what is the angle in between those? From 135 to 270 subtracted is 135, isn't it? So I would do 1 squared plus 6 squared minus 2 times 1 times 6 times the cosine of 135. Just kidding, cosine of 135. Making sure I'm in degrees. And then I do have to square root that at the end to find that distance, right? Or you can use the actual formula, which says you can leave them in negatives. It's the same thing. You just got to type real carefully, and back here at the end, it asks you to subtract them. Need a lot of parentheses for that one. Can somebody just okay that we did this one right so people in our at-home audience know they're typing it correctly? I got 45 before I square rooted, yes. And then if I square root, anybody getting that? 6.7? Which makes sense to me. It should be a little greater than 6 because of the numbers. No? 135. Okay. Okay. But the formula, there is a formula on the yellow sheet. I'm just worried about people typing it right if you don't practice it. All right. That's it. Last section is on the stuff we did Friday. The trick is going to be questions that ask you to do this. Go back and forth. This is a rectangular coordinate. It wants a polar. So if I went left 1 and up 5, how do I find the r and the theta? Okay, Pythagorean theorem would be square root of 26, and that's r. And it says you can round to the nearest hundredth. .10. Okay, that's r. Then I need theta. Here's the hard part, guys. What does it want theta in? Radians. Okay, so you need to do inverse tangent in radians of 5 over -1, and then you got to make sure it's in the right quadrant. Yep, this one you need to be in radian mode. Inverse tangent 5 divided by -1 is -1.37. Am I down in that quadrant, -1.37? Radians? No. How do I get it in the right quadrant? Add 180, but it's not in degrees. I have to add pi, 1 pi, because it's halfway back. I got 1.77 r theta, okay? If you were doing this number 36 here, you wouldn't have to add anything, right? Since it's a quadrant 1, give you the right answer. Yes. You can leave it in the square root unless it says otherwise. All right, I'll go back and do we have some going the other direction? Here's one going the other direction. We got to get to that question. Okay, let's talk about these though. This is on the yellow sheet. Remember at the top of this side? These both have 1s. That was very nice of me. I don't think the one on the quiz has a 1 there. Remember, you have to get a 1 in this spot. If you weren't here Friday, watch the video, but you have to have a 1 in that spot right there. Once you have a 1 in that spot, you find the equation on the sheet, which for number 44 would say that. So what is E? E is 0.3, which makes it a ellipse because it's less than 1, yes. And how do I find D? Well, the top here would say ED equals 1.2, but I know E is 0.3. So I divide and I get D is 4, yes? Straight up 4, okay? Now, on the sheet it will tell you that means the directrix equation, okay, is the directrix x equals or y equals? It's cosine, so it's x equals, but it will tell you right on the sheet. And is it positive or negative D? Positive, because it was positive here. Remember, E and D always start out positive. The negative will come with the equation for the directrix. How do we graph this? Because you have to be able to graph one or pick out the correct graph. What a mode do we need to be in? Polar and radians, okay? Mode, radians, and polar. Go to y equals. Your t, or your theta should be 0 to 2 pi by 0.1. It should not. Okay, what does this one come out? I got a 3-leaf clover, yes? Well, what you can see right here that this one's going out how far? 4, right? And if you have a whole circle divided into 3 even parts, it should be 120 degrees around to the next one. Yeah. Guys, we didn't get to this question and this concept is on there. When you're given the polar, how do you go back to the rectangular? Yes, this is just 6 cosine of 7 pi over 4 and 6 sine of 7 pi over 4. Now, if it happened to be a multiple choice question, it might be exact. I will take exact or decimal, but if you go to 7 pi over 4 on the unit circle, the cosine is square root of 2 over 2, and the sine is negative square root of 2 over 2. So the exact ordered pairs would be 3 square roots of 2, negative 3 square roots of 2. All right? Just finishing the video here. Inverse tangent, if you do negative 3 over negative 3 in radian mode, is negative 0.785, but negative is over in this quadrant. Oh, this should have been positive. So I would have to add 180 to it, or in this case, pi. So this would turn out 3 square roots of 2 and 2.36. And it is not, it does not have to be, you only have to give one answer for those on the quiz. You don't have to do two different ordered pairs. All right, so quiz tomorrow. I was just finishing the video. Okay.